About to do a live review for the quiz this week. So the plan is here going forward, the first class of each week on Tuesday, I'm going to review what that week's lesson is, just to summarize. I won't do all of the long, lengthy lessons that you have in Buzz with all the practice problems and all that, but I'll give you like a nice summary of what you're learning with any of the equations you're studying that week or anything, with the time for you to ask any questions, which includes questions over the previous weeks. But we'll have a nice time for questions on that, and all that will be available. But otherwise, I think we're ready to get started here. Let's go ahead, and I'm going to put this in. All right, let me ask one question first. All right, turn your cameras on. I'm going to do a show your hands. Show hands. Turn your cameras on. We're about to do a show of hands here. Let me see where I can see your hands. All right. Alicia, Fabrizio, don't see your hands. All right, here's a question. How many people know that you can use your notes on tests, quizzes, and assignments? How many people know that? Oh, I hope everyone knows that. Any test, any quiz, any notes you take, you can use those. So then the next question is, are you taking notes? Are you taking good notes? Here, I'm going to put up what I would have as my notes at this point, just for Module 8. I've just started Module 8, and I'm going to show you the notes that I've taken. And I've actually taken an extra note or two. We probably haven't covered yet, but here's what I have done. I took these notes that said, okay, we're talking about circles, talking about circumference and area of circles. So I did the formulas. Circumference is pi times the diameter, or it's pi times 2 radiuses, right? 2 times the radius, since the radius is half of the diameter. Area of a circle, pi r squared. I've got these, we're using these formulas here in 801, the volume of a cylinder, volume of a pyramid, volume of a cone. So I have those equations along with the words and the little diagrams just to help me remember what goes with what, right? If I just have these equations, that's not going to be very useful if I don't remember what those are used for. So this is for a pyramid. Now notice I did this as 1/3 times the base area times the height. The base area could be different. If it's a square, you got to figure the area of a square times the height. If it's a rectangle, you find the area of a rectangle times the height. If it's a triangular pyramid, which aren't as common, but they do exist, you find the area of a triangle times the height. 1/3 times the base area times the height. Now, see, I said, or if you don't like multiplying by 1/3, you can divide by 3. That's the same thing. Mathematically is equivalent. I can multiply by 1/3, or I can divide by 3, which means this will do the same way too. I can multiply by 1/3, or I can cross that out and divide by 3. So either one is acceptable for a cone. The cone is also the base area, but a cone is always a circle. So I just substitute area of a circle, pi r squared. Pi r squared is the base area. So 1/3 times the base area times the height for a cone. Cylinder. Cylinders have a circle base like a soda can. Pi r squared, circle times the height. A prism would just be like a box. It would kind of like, instead of a cylinder, it'd be like a square or a rectangle, length times width times the height. Again, B, the base area. What is the area of the base times the height? We have the volume of a sphere in these lessons. So a ball, a globe, a planet, something like that. The volume is 4/3 times the pi times the radius cubed. Radius cubed on that one. So, and this is from 802. Dimensions of similar figures, you can write them as a ratio. The dimensions of this one over that one, or the volumes would be the dimensions cubed, because if this is 2 times, if A is twice the size B, like the length of the sides, twice 2/1, this would be cubed, 2 cubed over 1 cubed, so it would be 8 times bigger. We'll talk about that. And I put the area of a rectangle down here just because we use it in these other calculations. So have some good notes. When I would take the quiz, when I take a test, when I do assignments, I would have these notes in front of me. And that way I have everything I need at my fingertips and don't have to remember it. Now, how did I make these notes? I made these real easy after I went through the lessons. did the practice problems, there's that last page, or sometimes the next to last page of the lesson has a summary of what you learned. And if there's an equation you learned in that lesson, it always has that on the summary page. So I went to the summary pages and said, okay, what formulas did we learn this lesson? And I wrote those down on my notes. And if there's any other things that I need to write in there and review, sometimes I need to do that. Like in my algebra class I was teaching, I had some formulas to write down, but I also had some stuff I just want, like vocabulary, a monomial, a binomial, trinomial, stuff like that. So sometimes you need to put more into your notes if there's some vocabulary that you need to have. But certainly equations would be great in your notes. So, all right, we are going to look at what is the quiz going to look like this week? What is our quiz? What kind of problems are we solving? So the quiz has like real life applications. Like we have these formulas, which are nice, but how do you use them? All right, so there is going to be a problem on the quiz that'll have like a cone. It'll have a drawing of it too, so you can see what they're talking about. And it's got this circle down here. So what this is telling us is this is like when you go to one of them snow cone stations. So we go get a snow cone, and they're saying, so they've got this cone that they're going to put your flavored ice in, and they put a gumball down the bottom of it. So they have this flavored ice, and they have a gumball in there, and so they're going to fill it up right to the top. They're not going to pile it up like we normally do in snow cones. They just want to know how much flavored ice do we need to fill this cone up. So they'll give us information. They said, okay, so the radius of this cone is 1.5 inches. So that would be halfway across, right? That's the radius. Radius, 1.5. And they said the height of this from the top to the bottom of the cone is 4 inches. So we have a height of 4 inches. And they said this gumball right in here has a diameter. So this diameter is how far is it from one side to the other side, all the way across. A diameter of 0.5 inches. So it's half an inch gumball, half an inch gumball. And you're asked to calculate how much flavored ice in there. Now, it may have different numbers on your problem. I just made these numbers up for this one. But we're going to talk about how does this work? How is this used? So for that, we need, first off, volume of a cone, right? This is a cone. So for the volume of the cone, we're going to use volume equals, I'm going to do the divided by 3 version. How about that? Pi r squared h divided by 3. That's the same thing as multiplying by a third. I'm just dividing by 3. Make it work easier in my calculator. That's our cone. What else do we need? Well, we can't fill all of that up with flavored ice because there's a gumball down in the bottom. So we have to subtract out the volume of this gumball because we can't put flavored ice there. Well, that's a sphere. So for the gumball, we need our volume of a sphere, 4/3 times pi times the radius cubed. So there's our 2 formulas that we're taking from our note page and using on this problem. So first, let's calculate. Let's do the gumball. So here's our formula. Let's substitute what we know. Well, there's not much that has to be substituted. 4/3 is a number. Pi is a number. All we have is the radius. Well, this didn't give us the radius. This gave us the diameter. Pay attention to those things because sometimes, and in this problem we got both, sometimes they give you the radius, sometimes they give you the diameter. Right? So we have to pay attention. Now with a circle, right, the diameter is all the way across. All the way across through the center. Through the center. A radius is just from the center to halfway across, right? Halfway from the center to one edge, halfway across. So if half of the diameter, if that's 0.5, half of that is 0.25, right? That's a half, that's a fourth. 50 cents and a quarter, that's half, right? So this is the radius of our gumball. So for our formula, we need to do 0.25 to the 3rd power. Well, now we're ready for our calculator because we've done everything we can do there. And on these calculations, unless sometimes Buzz will tell you, sometimes Buzz says use 3.14 for pi, right? Sometimes it'll say that. In that case, we'll use that instead of pi. We'll use 3.14. If it does not say that, use the pi button on your calculator. This calculator has a pi button right there. Your calculator will have one somewhere. It'll show a pi. Use that button in your calculation. Don't round it to 3.14 unless it tells you to. Otherwise, we will round it at the end, not before we start there. So 4/3. We can do 4/3 by parentheses 4 divided by 3. So that's 4/3 times pi. I'm using that pi button times 0.25 to the third power. Now you can put to the third power on here, but let's just break to that what it is. 0.25 to the third power is 0.25 times 0.25 times 0.25. That's 0.25 to the third power, multiplying itself 3 times. 0.25 times 0.25 times 0.25. So all of that equals 4/3 times pi times 0.25 to the third power equals 0.065. Let's round that to 2 decimals. We'll say 0.07. The 5 makes that 6 at the round up. We're going to 2 decimals. We look at 1, 2. The third one tells us whether or not we have to go up. We do. It's a 5, 5 or greater. We go this to a 7 now. So that's the volume of our gumball right there. So let's find the volume of the cone. Volume equals pi. R, the radius of this is 1.5 inches. 1.5 squared times the height. They gave us the height of 4 inches. All of that divided by 3. So go back to our calculator and let's put this in. All right, so we're going to take pi times 1.5 squared times 1.5 times 1.5, or you can use the squared button. I just did it this way. Times 4. So that's everything on top. Pi times 1.5 squared times 4, which equals this. And then I'm going to divide it by 3. Leave that answer. Divide it. Take the answer. Divided by 3. 9.424. The 4 rounds down. So 9.42. So that is the volume of the cone. That's the volume of the gumball. We got to subtract the gumball. So we subtract the 0.07 from the volume of the cone. We can put 9.35 cubic inches of flavored ice in our snow cone. 9.35. That would be the answer you would look for in Buzz if it has multiple choice. If it's not multiple choice, that's the answer you'd give in Buzz, 9.35. But we did the volume of a cone. We did the volume of the gumball, volume of a sphere. Plugged in the radius, the height when needed. Once we substitute those in, we just used our calculator to find the answers and subtract that. So you will have a problem like that on the quiz. Let's see what other kinds of problem we have. There will also be something like a grain silo. You haven't worked on a farm, you've probably seen one of these if you're driving across the countryside outside the city, and it'll have a picture of one there, a grain silo, and it's a big cylinder. All right, and you can't see the back of that, but it's a cylinder. And on top is a big dome. You see these out in the country when you drive around, big grain silo. And, they fill them up. There's a hole right in the top, and they run this pipe, and they have grain in it, and they will funnel the grain in through that pipe and fill the grain silo up with grain. And so our assignment on Buzz may say, okay, this grain silo from here to here, the height of that is 100 feet. And this has a diameter of 14 feet. And it'll say, how much grain can this hold? And that's all it'll tell us, right? It'll give us the height of the cylinder, the diameter all the way across, and ask how much will this hold? Well, we have 2 things here, right? We have a cylinder and we have this dome. But that dome is, wrong sheet. That's this sheet. Half of a sphere, right? If we took a sphere and we cut it in half right across the middle, that's the dome. That's the part put on there. So we take a sphere and we take half of it to get the cylinder. So let's get the equations that we need here. For the cylinder, All right, the volume equals pi r squared, which is the area of a circle. That's the base. That's how big this is, times the height. So we know how big this is and then how tall. That's how much the cylinder will hold. The sphere, 4/3, same formula we used up here, times pi times the radius cubed. But when we're done with that, we got to cut it in half. We got to divide all of that by 2 because we only have half a sphere this time. So we want to take all of that and divide it by 2. So let's work through that. We'll do it the cylinder first. Volume equals pi. Okay, what's our radius? Oh, again, they did not give us the radius. They gave us the diameter this time. So if we have a diameter, we got to cut it in half to get the radius. The radius is 7. Diameter 14. So the halfway point would be the radius 7. Half of that circle, from the center of the circle to one side, radius 7. So 7 squared is our radius squared, and then the height is 100. So let's find the volume of our cylinder right here. Pi, again, make sure you use that pi button because it didn't tell us to use 3.14. If it does tell us use 3.14, we would use that. Otherwise, always use the pi button. Times 7 squared. 7 times 7 is 7 squared. Times 100. Pi times 7 times 7 times 100. 15,393.8. I'll round it to 1 decimal. 15,393.8. Okay, that is the cylinder part. All right, that's this. Let's get the dome. So volume equals 4/3 pi. Okay, those are constants right there. No variables yet. Radius cubed. Well, they didn't give us any information about that. How big is our sphere? Well, the radius has to be the same as this. The cylinder is the same size from top to bottom. So if this radius down here is 7, then this radius here is 7. And that is the radius of our sphere. And we'll divide all that by 2 when we're done. So let's calculate that. Parentheses 4 divided by 3. There's our 4/3 times pi times 7 to the 3rd power. I'll do it the other way. I can do 7 raised to the 3rd power. See, I'll get this little raise button right there, 7 to the 3rd power. So if I do that, that's the top of my fraction. I need to divide it by 2 because I only need half of a sphere. So the volume of the dome is 718.4 because I got 0.37, so it rounds up to 0.4. So what's the total volume of our grain silo? We take our 15,393.8 and add to it the dome, how much it will hold, 718.4. And we add those together, 16,112.2. And that is cubic feet. Volume is always cubic. Volume is cubic units. Volume is cubic units. All right, so you will have a problem like both of those on this week's quiz. Let's see, there's 5 questions total on the quiz. What else will we have on there? Oh, yeah, you'll have another problem. I'm just going to show you what it looks like. We're not going to work through this one. You have another problem that has like a sand dial. You've seen those big sand dials? Maybe you've played a board game that has a dial in it, but it'll have sand going through a funnel, right? And then there's on bottom's just a mirror image of the same thing. So it'll be filled up with sand. Oh, sorry, let me move that where you can see it. You'll have a sand dial, and it'll be like so much sand in here. So all this is sand down to there. And we're trying to figure out how long of a timer is this, because it'll use that sand. That sand will fall through there. When the sand's out, the time's up. So it will tell us like how high is the sand. Like all together, let's say there's 40 millimeters of sand. And it should tell us maybe the radius or diameter. Like this diameter here would be, let's say it's 6 millimeters. 6 millimeters from left to right, the diameter. And it'll tell us a rate. It'll tell us how fast it's falling through there. It might say that it falls at a rate of 10 cubic millimeters per second. Because when we find the volume, we need to find the volume of how much sand is in there. When we find the volume is going to be in cubic millimeters, right? Whatever it ends up being. Let's say we do all the calculations and it turns out to be 150 cubic millimeters. Well, if it's falling at a rate of 10 per second, that means this is a 15-second timer, right? We just divide 150 by the 10. But to get this, you're going to have two calculations again. This part here, from there to here, that's a cylinder. And this part down here is a cone. Right? So you've got a cylinder and a cone. And so it should somewhere tell you the height of this cone, because we need to know how much of this 40 belongs to the cone and the rest of it will belong to the cylinder. So it should give information that the cone is 10 millimeters tall or something. It'll tell you something about the height of the cone. So you know what height to allocate to the cone, and then the cylinder would get the other 30, because there's 40 altogether of sand. So 10 go there and 30, or whatever numbers they give you. Like I said, I'm making these numbers up. Pay attention to what numbers they're giving you. I'm just showing you the concept of how you need to work that. So you would find your volume of the cylinder using the height of the sand, and then find the volume of the cone, add them together, get your total, and then divide that by how fast the sand's moving. And we come up with, 15 seconds. And again, I just made this up, so this may not match these numbers. I just made up the answer just to show you what that looks like. Let's see. The other two problems don't require a lot of work like those did. It'd be a little bit simpler. You'll have one problem that, let's say, maybe it gives you a box. I don't remember what shape it talks about. And it may not even give you a picture. It may just be words. But let's say you have a box. And this box is 2 by 2 by 2. And it may ask you if we double the dimensions of the box, right? Now the box is going to be bigger, and it's going to be 4 by 4, and the height is going to be 4. We have doubled the size of the box. It'll say, how many times bigger is the volume of this box compared to the original box? How many times bigger? Is the volume twice as big, or is it more than that? Well, let's look at the volume. If you're not sure, just take a calculation of the volume. This is a box, a square prism. It's the length times width times the height. Length times width times height is the volume. 2 times 2 times 2. That's 8. 2 times 2 is 4, times 2 is 8. So the volume of this box is 8. If this is twice as big, does that mean the volume should be 16? Let's see. The volume here is 4 times 4 times 4. 4 times 4 is 16. Times 4 again is 64. How many times bigger? The volume is 8 times bigger. We made all the sides times 2, but the volume got 8 times bigger, not just 2 times bigger. Why did it do that? Well, what if I said instead of 4, I'm going to write this as the original 2 times 2, because we got twice as big. 2 times 2, 2 times 2. So then we would figure the volume as 2 times 2 times 2 times 2 times 2 times 2. So this was the original volume, and that was the original volumes right there. But we've added another 2 times 2 times 2, which is where we get the 8. Because the the times 2 is being used 3 times. That's why it got 8 times bigger. If this was 3 times bigger, if this went from 2 to 6 to 6 to 6, this would be 3 times 3 times 3 bigger. Or 3 times 3 is 9, 27. This would be 27 times the volume if this was 3 times bigger than that. And let me see. I can illustrate that a little bit. Kind of think about it. What if we had a piece of paper? I'm going to turn this sideways to help the thing. And I have this other piece of paper. And this piece of paper here is half of the size. See, it's half. See how it's only half? And it's half as wide right here. If I have 2 of these, I'd be exactly the same size. It's half as wide. So this piece of paper is twice as big as this one. It's twice as long and it's twice as wide. But it takes 4 of these to be the same area because it's times 2 times 2. So that's times 4. And then if we had height, like a box, we'd have 4 down here times 2, we'd have another 4 on top. So that's why when you have that scale, the scale of times 2, we're using it multiple times, 2 times 2 times 2. So the volume gets 8 times bigger. So they're going to ask you a question like that, asking how many times bigger. And then they're also going to ask you a question. They're going to try to fool you because they're going to ask questions 2 different ways. The same question 2 different ways. Then they're going to say, okay, I've got a pyramid or whatever shape they use. I think it's a pyramid. And now I've got a bigger pyramid. And they're going to say this pyramid has a volume of 30. And this pyramid has a volume of 60. And they may tell you that the base of this one is 8. Yeah. They may tell you some information like that. Or they may tell you the height. You know, the height is 10 or whatever it is. And it's going to ask you, how many times bigger is the volume of the large one compared to the small one? How many times bigger is it? Well, here's the trick to it all. This one we had to calculate what the volume is to tell how many times bigger it is or know how the rule works. This one we don't because they told us the answers already. This is the volumes. This one, the volume is 2 times bigger because this one's 30 and this one's 60. 30 times 2 is 60. See, this one was 8 and 64. That's 8 times bigger. But they didn't give us that when we had to calculate it. This one, they're going to actually give you the volumes and ask you how many times bigger it is. And you're going to think there's a whole lot more math involved in that. And you're going to pull out some volume formulas and you're going to start trying to figure things when they've already told you the final volumes. You don't need to calculate anything other than how many times bigger is this than that. Well, this one's times 2. So don't make this one harder by trying to do a bunch of equations. You don't need any equations. Just take 60 and divide it by 3. That's 2. This one you may have a little more work to do. So that is the 5 different kinds of problems you will see this week. And if you have a good note sheet, like I said, here's my note sheet. If you have a good note sheet that you're keeping and adding to as you go through the lessons, by the time you get to the test at the end, you'll have this wonderful thing of notes. And if you have a 3-ring, a spiral binder or a 3-ring binder or something, you keep all these notes in, you'll have them all in one place. So we get to the end of the semester, for like the final, you'll have all of your notes all in one place. So keep them in a 3-ring binder or a spiral notebook or something, but add to your notes as you go through the lessons. Add to your notes. So does anyone have any questions on anything that we covered there, or questions from other things that maybe I didn't cover? But I tried to cover all the important stuff from the first 2 lessons that you will see on the quiz that's due this Sunday. So if there are no questions, if you received an email Friday that you're supposed to be in class because your grade's below 70%, then you need to stay and be working in Buzz during this class. Otherwise, you're here optionally. That's great. You are free to go. I'm planning on doing this every week on Tuesday. I'm going to give a little review of that week's lesson. So you can come every Tuesday and see this if you like, but it's optional if your grade's over 70%. So those of you who are here optionally, glad you came. You should be able to nail the quiz this week. Got some good information there. If you have questions, hang around and ask. Otherwise, either get to work or go off and enjoy your day.